Hello. So this will be a fairly quick one. Um, we covered pointers and using pointers and classes this week, so we're going to go over something called the Big Three. So first off, let's talk about what is a class, because I didn't really make a video on classes. So with classes, it's kind of like if you have code that you've used already, or like code that you've made already, and you want to reuse it in your program, well, then it helps to import that code you've already used into a new program. And that's one of the benefits of classes. So I think classes as kind of um, like pre-made uh, code that you can then import into your um, main CPP file. And these classes typically exist as a special file called the header file. So normally any code that ends in .cpp, so these are called driver files. And these driver files are where you basically write all of your code, like the code that actually runs. So your typical int main function, you can write any functions above, you can have your body, and then once your main program is done, then you just return 0. Cool. And then, and yeah, so that's kind of that. So a header file is where you can define a class, and then you can import that class to use into your main, and you can access all of the functions that you have defined in your class. So hopefully kind of makes sense what a class is and why it's useful. It's essentially pre-written code that someone else has made or that you've made, so you can now use it in your main function. So like rather than just like writing a whole bunch of code in your main function, it would be more convenient if we could just compartmentalize that code and then import it and then use it in our main. It's much cleaner and kind of things like that. So like when we do things like hashtag include like IOStream or vector, these are kind of this is kind of the same thing that's happening here. We don't actually have to code up vector or IOStream. It's pre-made for us. And when we do hashtag include, we are importing them into our main program so we can use them. So yeah, that's kind of what classes do. They kind of do the same thing. And we do use the include um, hashtag, I think. So So classes can be broken up into two main segments. So when we're declaring the class in the header, so a class has um, a private and a public. So a private are like private like variables that you don't want like other people to access directly. So for example, if you wanted to make a bank account class, you wouldn't want to make someone's bank balance like public because then they could hey, just make my balance equal to 9999999 and I'm rich. So we want to keep certain variables private. So we can have like integers, any type of like data type you want. But let's use integers for this example. And then we're going to have like public. So the public methods are ones that the main function will actually use. And these public methods will end up interacting in private methods with our private variables, but the main function won't have a direct access to the private because like in the bank account example, we don't want our customer to like make their bank balance $999 billion. So we have to keep them private so they're not easily accessible from the main. And then in the public, we are able to control how they're accessed, when they're accessed, and things like that. So in the public, we tend to make a few things. We tend to make a constructor. We'll have like functions or like methods. You can call them whatever you want, kind of the same thing. And yeah, so we have constructors, functions, and methods. And what the constructors do is the constructors help to instantiate these private variables. They will like start them up. So for example, if I have a balance, so for example, I do int like account. I'm just good doing a bank account example because that's what's given in 1181 and it makes a lot of sense. Um, so the constructor would start off and initialize a balance to 0 and then generate an an account number. And then so that's what the constructor does. It just helps to instantiate these private variables. So these later functions such as deposit, withdrawal, close, things like that can happen. So we can deposit money and that will add it to it. We can withdraw money and that will take away from it. We can close the account, which will do something to this. So yeah, kind of things like that. So that's kind of how classes and um, that's kind of how classes work. And like I said, we could implement this all in our main, but that would make our main really long. So it's better to compartmentalize it into a separate file. And then this way we can import our header file into any other program we want and then use our functions that we've made. So that's just a quick breakdown of what classes are. And something to note. So it's helpful so we're going to talk about like pointers and using pointers with classes. So remember how I said with pointers. So pointers point to memory. And remember how I said for memory that we have access to, there are two types. There's like static memory, and then there's dynamic memory, also known as the heap. And the static is like also known as static and the stack. Anyways, we don't really need to worry about the fancy names. We just need to know that there's two different types. So static memory is handled for you automatically. So the compiler, the operating system, it automatically takes care of static memory. So everything's taken care of and you don't have to like manually like do any fine-tune controlling over it. However, dynamic memory is in manual mode. So dynamic memory we have to like we have to make sure it's being cleaned properly. We have to make sure we remove it when we're done with it and things like that. So dynamic memory is where a lot of the headache really comes in from. And you know something's dynamic when we use a new keyword. So whenever we use new, it means we're going to make something in the dynamic memory. Everything else basically lives in static, although some things do new behind the scenes. So for example, if you do a vector, a vector, we never do new vector, but a vector does when we construct it. When we're constructing the vector, it will do new behind the scenes. And that's kind of what we're going to do today. We're basically going to use pointers in our class to do some dynamic memory stuff behind the scenes, just like how a vector does. So these pointers, they live in the static memory, so the pointers are kind of taken care for us automatically. But sometimes the memory that these pointers point to, we'll have to take manual control over it. So something to keep in mind is that whenever we make a class, there are three things that we have to take control of whenever we do manual mode. So classes have these automatic functions that are automatically made, and they are the constructor, they are the destructor. So so the constructor ins instantiates these private variables, and the destructor, I'm sure you can guess what it does. What it does is it'll destroy these private variables. But if we're gonna use dynamic memory and our private variable ends up having a pointer in it, the default behavior destroy, is to just destroy these. But if we have a pointer that's pointing to dynamic memory, well, before the pointer is deleted, we have to actually destroy what's in dynamic. So, so that's one of the things from the big three. Um, the big three. So one of the things from the big three is a destructor. And and again, the only reason why we have to worry about this is because classes by default are automatically taking care of the static memory for us, but they do not take care of the dynamic memory, which is all manual. So we have to take care of the dynamic memory. So things that we have to watch out for are to make sure that our destructor works properly. We also have to watch out for something called our copy constructor. So what a copy constructor is let's say you have a class and you want to make a new, like, well, I won't do a new, and you want to make another class object, and you want that class object to be equal to this previous class that we had before. So what we're essentially doing here is we're asking it to copy over all of these values into this new class object. And that's when the copy constructor is called. So one example would be is, let's say that you have a bank account and you want to give your bank account to someone else. So you want to move your bank account into someone else's bank account. It could be your mom or dad, your husband or wife, or anyone who you trust a lot and you want them to have your bank account because you're like leaving the country and never coming back or something like that. So then what would happen is that they would want to have their own bank account, but they would need to copy over everything that you have. So that's where the copy constructor is valuable. So we have another class object in here, and this copies everything over. And like I said, anything in static memory is automatically taken care of for us. And the copy constructor by the default takes care of all the static stuff. But if we have anything that's in dynamic memory, such as this pointer, then we have to make sure we're cleaning up and doing everything proper when it comes to the dynamic. So the real thing is like whenever we're dealing with dynamic memory, things are in manual mode, and we're going to have to take care of some of the things that typically C++ takes care of us for us, which it normally would if it was a normal class object, but whenever we're dealing with pointers that point to dynamic memory, we have to take manual control over these three things. So the destructor, the copy constructor, and then lastly, the equals operator, or actually operator equal. So what this is going to do is this is an assignment. So let's say that we want to, I don't know, let me think. What would be a good, yeah, I think the example would be like this. So like let's say you wanted to kind of like copy everything over, but not directly. So we would do class A equal to B, and we have class B. So what happens here is that class A is now going to inherit everything that class B has. And then once this equal is done, what this is going to do is this is going to then invoke the copy constructor, and then everything's going to be copied over. So we have to make sure that the program knows how to do this assignment properly. So essentially this equal operator is actually related to the copy constructor. So anyways, these are the big three things that we have to take care of, because by default, classes have every single class that you make will have these three things automatically there, even if they're not like actually shown to you. And they work automatically with like static memory. But whenever we have pointers that point to dynamic memory, well, then our life gets a lot harder because now we have to manually take care of these three things and like in every single class we make. And that's also what our quiz is really going to be on. So yeah, that's kind of what I'm going to go over today. The destructor, which clears out like memory and typically runs when our program terminates or whenever we stop using our class object. The copy constructor, which is to copy data from one class to the other as long as they're the same class. And then the equals operator, which is assignment, which is used to assign one class to another. So these are the three things that we have to take care of. And that's what I'm going to go and show you guys today. Okay, so like I said, we have to make a header for every single class. So I believe, okay, I might get this wrong, but we have to start off with, okay, let's make sure that our class file is not like already named. So we do if not defined, then our class name is gonna be, let's just call it big3. Okay, that doesn't work. Okay, is it like this? If undefined, if undefined. Okay, man, I hate the, okay. Yeah, it's like that. Wait, hold on, why is that? If and def. Okay. Okay, I'm not sure why that's red. So if undefined, we are gonna define our class. Okay. Sorry, define. Cool. Okay. And then we also need a end if at the end. Cool. Okay. Yeah. So our class is going to call Big Three, or actually, I should probably name it something else. Let's call it yeah. Why don't we go with the bank example? Bank account. Yeah. And I'll just rename this. Cool. Okay. If I'm defining, I'm gonna define it. Cool. So how we make our class is we type in class, and then we type in the name of our class, and we'll call the class bank account, or just call it bank. And then we have to also put a little semicolon at the end. I'm not really sure why. That's just how it is. And like I said, our class has two things. It has a public part and it has a private part. And the private will do something like it will have a, let's say we want to make our, let's just keep it simple. And let's say we want our bank balance and we're going to use a pointer, which makes it live in dynamic memory. I'm not really sure why you would want to use dynamic memory here, but we're just going to use it for demonstration's sake. So we're going to do int balance and just like that. So we have one private pointer and its name is balance. And we're going to make some public methods that we want our driver file to use. So first we need to construct it. So, oops, we don't actually define. So it has to have a blank constructor or like a default constructor. Also, these we can do one where they type in how much they want to start off with. We can do bank. We can do a withdrawal function, and then we can do a deposit function. Cool. And then, like I said, the big three, we have to do a destructor. We have to do a copy. So bank, bank. So that's our copy. Also, wait, why are these red? Function define with, okay. Okay, let's ignore that for now. We have to do an assignment operator. So that would probably return a, so the assignment operator needs to return a pointer. And operator equals, and then bank A. Cool. And then, so our big three, we have a destructor, we have the copier, and you have the equals operator. So big three. So 1, 2, and 3. And I think just for sake of time, I'm probably, well, these will be pretty easy to do. Cool. Okay, what's this for? Let's see. The copy constructor may not have Oh, why is that? Is it because it has to be a const? Okay. Oh yeah, I want to mention const and reference. By default, try to make everything that you know a const and a reference. So what const does is const makes it read-only. And const also helps our compiler do special tricks to make our code run faster. So const is good as long as you know that you aren't going to modify it. And the ampersand means that's reference. So meaning that we're going to pass it in by reference, meaning that we aren't actually going to make a deep copy, a, a whole new copy of this bank object and modify it. We want it to refer to the original one. So we're passing it in by reference. And references are much lighter than passing in whole copies of whole objects. So that again also helps with speed. Cool. So I think also this can stay, and I don't think we need to modify. But actually, no, I think we might need to modify bank. There equals. Cool. Okay, this is just complaining. But yeah, normally I'd have this, but I'm not going. Actually, maybe I should. Okay, so yeah, so we have these three. So these are the functions that we're going to have access to in our main. And how we include that is we do hashtag include, and we do bank acc.h. And let's include iostream. Okay, why is that? Oh, yeah, we have to use uh, these quotations. Okay, let's get our basic driver function working. Cool. Okay, so let's start defining our class. So let's make the constructor. So now we are outside of the class, so we have to make sure that our program knows what we're talking about. So we're going to end up using something called a namespace. And remember how we do std dot semicolon count? So basically count is like a function just like this, and it belongs to the standard library, which is kind of like a class. So we kind of have to do the same thing here. So I have to do bank, double semicolon, and then bank. So that's how we define the default constructor. And the default constructor is going to be very simple. All it's going to do is it's going to do balance equal new double and make that equal to 0. Okay. Oh, cool. Okay. Now let's do a bank that has a default balance. So let's do double balance. So here, if we do balance equal new double balance, we kind of run into an issue. Our computer program doesn't really know which balance we're talking about. Are we talking about this balance or are we talking about this balance? So a helpful thing to do is to use this keyword. So this keyword, so what this does is we help it to understand which function it's talking about. So we can do cool. So what this is really doing is the this keyword is going the this keyword is kind of a pointer in itself. So the this keyword is a pointer to a bank object, the bank object that we're in right now. And what it does is the arrow function right here will dereference the balance. So what it'll do is it will be like, hey, I am currently talking about the balance, and I'm gonna dereference it so we can read what it's pointing to in this object. So that this means this object we're currently in, and we're gonna dereference, meaning we're gonna read what the pointer's pointing to, and we're gonna make it equal to a new balance. And this will naturally be this balance. And that this thing will actually be talking about the balance over here. So this way the computer program knows which balance you're talking about. If, for example, you named it something else, like amount, then this would still work, but you wouldn't need to use the this keyword anymore. So the this keyword really helps if you have two variables with the same name. But I do recommend practicing using this. I feel like it'll probably be tested. Okay, so we have, so this is another constructor that we've made. So let's do the withdrawal and the deposit really quickly. And again, just for the sake of compiler optimization, since we're not actually modifying anything, we can make things faster. I spelled double wrong. Cool. So here, what we're gonna do, oops, I did this. Cool. Okay, so here, what we are gonna do is we are gonna withdraw the amount. So what we're gonna do is we're gonna dereference the balance. So we're gonna do balance. Let's think. Balance equal to. We could probably do something like this. Wonder if this will actually work. So this will dereference it. Let's see. Let's see what happens if we just do balance equal to. Well, actually, first we wanna read current amount. So we're gonna see what the current amount is. I'm gonna say if the amount that we want so if the amount, actually we don't really need a current. Minus amount. So what we're basically saying, wait, hold on. So what's, if we do 4 minus 10, if you take 4 as fact, yeah, okay, cool. So what we want to make sure is that we can't have a negative balance. So if the balance, so if so right now we're going to read what the pointer is pointing to, which is the actual balance that we have, and you minus that from the amount that the customer is requesting. And then if it is greater than 0, or actually greater than or equal to 0, then we're going to actually let them do it. So we're going to make, we're going to, yeah, probably should have a current. I think how I should do this. Yeah, probably just make a current. Or current. And now what we're going to have to do is we're going to have to, actually, we can just modify it. Don't have to make a new one. Okay, yeah, that can work. And then we can do some out. Okay, and this is red because we haven't imported IO stream. So cool. Okay. Oh, we have to do, we have to include what this thing is going to return. Cool. And if this doesn't happen, std out. Let's be a bit mean. Cool. Okay, so that's my withdrawal method. And let's do deposit. And let's also do const amount. And what deposit is going to do is deposit is going to de-instantiate balance and make it equal to amount plus balance. Cool. And then we can do std out 6 deposited current balance. Actually, I should probably make a current balance function, but I'm lazy. And we're going to do this twice. Cool. So we have this check, this check. So now let's make our destructor. So our destructor has to use the same namespace, bank, but it has a tilde bank. So what this is going to do is, so like the compiler it's going to take care of the static memory for us, and we just have to take care of the pointer that whatever this is pointing to, and that's pretty easy. Just use the delete keyword. Delete balance. And we should probably make a little print sign. So bank account object deleted. And this is just optional. I'm just there just so we know when the destructor ran. Cool. So now let's make our copy constructor, which is this one. So what this is going to do is it's going to take another bank account object and it's going to copy its values into this other bank object. So we're going to use what's this method signature? I'll just copy and paste. Cool. Actually, we could probably run it now and see if it works. Okay, let's do, what's our class? Yeah, bank. So let's call this bank account my account. And let's add in $100 and then do my ACC. Let's just deposit $1. Let's do my ACC withdrawal. Let's withdraw $102. And then let's try to withdraw something more meaningful, which is like $50. And then, yeah, I think that should be it. And let's see what happens. Okay, let's see, what's it saying? Oh, yeah, it's case sensitive. Okay, okay. So we successfully deposit. So first we make a bank account and we added $1 and it's gonna say, yes, we deposited $1. And then we're gonna try to withdraw $102 and it is gonna tell us we're broke. And then we're gonna try to withdraw $50 and the current balance, oh, it tells us we're broke both times, so that's a small bug. So let's just return at the end. So it doesn't tell us we're broke each time. Cool. So now it doesn't tell us we're broke twice. And then once the thing runs, our bank account gets deleted. Okay. Okay. So our bank account's working properly and our destructor is working. Okay, now let's worry about the hardest two, which are our copy constructor and our assignment operator. Okay, so our copy constructor is the second thing we have to take care of because we're dealing with dynamic memory here. So let's, oops, I didn't mean to do that. Okay, so let's copy and paste. Let's make sure you're using the same namespace. And cool, so this is our copy constructor. So what this copy constructor is going to do is it's going to take, this is to like copy everything over from one bank account object to the other. So let's think here. What's the first thing we need to do before we can start copying everything over? Well, everything that our current bank account object has needs to be properly deleted before we can copy new values. So this balance needs to be cleared. So let's do std count. Or actually, we don't really need to, but I prefer to do it for demonstration purposes. Okay, I'm gonna do deleting current balance. Dun 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 dun. Delete balance. Dun 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 dun. Okay, and now our dynamic memory is taken care of. So now we can just do whatever we need. So now what we can do is we can do this balance is now going to be equal to a new double, and it's going to be equal to, we're going to read what the balance A has. Cool. And then I'm going to do is copy success. Cool. Copied successfully. Cool. So what this is going to do is, because we're dealing with dynamic memory, we have to take manual care of our memory. So we have to delete what's in balance already. And then once our balance is deleted, we can then make a new piece of dynamic memory and copy over the balance from it. And the reason why we have to do this is because if we never deleted it, this piece of memory would still be there and nothing would be pointing to it. So it would just be hogging up memory for no reason. And this can cause issues because then your program is taking up extra memory that it doesn't need to take up, which is bad because we should only use the memory that we need to use because we're efficient people. Okay. So that's what bank does. So now we have to do the assignment operator. So let's just test and make sure everything works. So do, I'm gonna inherit Bill Gates's bank account. Cool. So he has a lot of money. I don't even know how many zeros this is, but that's a lot of money. Okay. So now what I'm going to do is actually I shouldn't name it Bill. Cool. So now what I'm going to do is I'm going to copy over Bill's money. Cool. Let's see. Does that work? My account. Okay. Bank account A. Yeah, that should work. Oh. Oh, this is because my account's already been made. So if I was to do bank of my C, let's do trust fund. Cool. So let's say I'm Bill Gates' kids and I get Bill's money. And now I'm gonna do trust fund withdrawal. And let's say I want to go to college and I need how much money is that even? Like 10 million? Yeah, that's 10 million. Let's say I need 10 million, and then I should be able to do it because I'm Bill Gates' kid after all. Okay, we ran into an error. Okay, let's see. Bill pointer being free was not allocated. Okay, deleting current balance. Cool. Hmm. So one of our pointers didn't work properly. Let's see. Oh, yeah, it's because of this. Because we're deleting the balance that we don't actually have. And it's like, hey, I don't know what you want me to delete. Okay. Well, actually, you would probably never really do this. You do the equals, but okay, let's just make it work for this example. Okay, oops, how did that happen? Okay, I think this should work now. Cool. My current balance is so big that it doesn't even show properly. Awesome. So yeah, my copy constructor is working properly. But but the thing is, like, we don't really want to make the copy constructor like this. How we really want to copy stuff is we want to do um like my oops, my trust fund account is going to be equal to Bill. So I'm going to inherit all of Bill's money. So that's how we want to do it. And this way, what ends up happening is that we have to overload this assignment operator. And yeah, that's what we're going to do. So we're gonna keep this. So our balance stays. So yeah, let's make some changes. So first I'm gonna have to make a trust fund object, and I'm gonna be broke. I'm gonna be born with nothing. And then I'm gonna copy over everything that Bill owns. Cool. Expression must be a modifiable object. Cool. Yeah, okay, I'll override this. Okay. Okay, so let's override it. So we are still in the bank namespace, and we're going to return a bank object as a reference. And it's going to be operator equal, and then, okay, don't yell at me. Okay, hold on. No, it has to return something. Cool. Okay, that should work, and it's going to uh, bring in a, I think we can make a const percent %a. Okay, stop yelling. Okay, good. So what the signature really means is like, I am going to return a reference to a bank account object, and it's going to be the equals operator. So whenever we have this, it means that the left-hand side will also be a bank object. If we wanted the equals operator to work on something that didn't have a bank object on the left-hand side, that's when we'd enter in the friend functions. But let's not do friend functions for this example. Or maybe we can, but after. So yeah, so now we're going to override the equals operator. And so let's think here. Okay, what do we have to do? Okay, um, what we're going to have to do is we're going to have to, we're basically going to have to do the same thing that's here. Oh, what we could do is we could have a is we could have a is we could have a check. So actually if balance not equal to null. Cool. Actually, I think this will work. So I think okay, I actually think this might work now. Non-void function. Okay, I'm gonna ignore you. Yeah, that actually works. Cool. Yeah, so we needed to make sure that I didn't have a null pointer. And yeah, that's awesome. Cool. Okay. So let's take care of the equals. So first you have to make sure that doesn't equal like so first you have to do is okay, if the thing we're copying over is not able to null pointer, then we're going to delete the current balance. Um, and then what we're going to do is make our balance let's just use the arrow function, or the arrow function already needed, but whatever, let's use it. So our balance is now going to be equal to a dot balance. New double, and we're going to dereference a dot balance. Cool. And we're going to print out copied successfully. Cool. So yeah, this should work. And we also need to make sure that it doesn't point to itself and ends up deleting itself. So if this so So the thing is, like, there's an edge case where if we make it equal to itself, it will end up deleting itself and it'll try to copy over something that it just deleted. So you have to make sure we handle that. And how we do that is we do if this, so this is a pointer here, is not equal to n% a. So if the pointer that's pointing to my current function isn't the same pointer that's pointing to the a function, so making sure they're two actual different objects. And then yeah, I'm gonna do this. Cool. And yeah, cool. If not, I'm just gonna do yeah, cool. Okay, you don't really need the semicolon. And the return this is because this thing expects a um expects a this thing is gonna return a pointer and the pointer has to point to something. So we're gonna dereference this and actually let it to point to what we actually wanted to point to. Okay, I think that should be it. Okay, let me make so we can do withdrawal. And let me do let's like uh let's say that Bill took away my money and they didn't want me to have money anymore. And now, because I'm a spoiled kid, I'm still gonna try to withdraw $2,000 because I wanted like a new gaming PC. Cool. So yeah, I think that's it. That's how we really make a class. Oh, let's to make a print function. Okay. So here, I'll just explain it. And it's been an hour. Okay, I'll just explain what I've done. So I make a bank account object using the constructor. I'm gonna drag this here. I make a bank account object using this constructor. I make another bank account object using this constructor again. And then here I'm using our copy constructor and I'm making a new bank account object where I copy over whatever Bill has. And here I'm just doing a bunch of deposits and withdrawals on my own account. And then, because now I have everything that Bill has, I'm going to try to withdraw it. And then later on, Bill Gates doesn't want to be my daddy anymore. And I get downgraded into being broke. And I only have $100. And then I try to withdraw 2,000 because I have bad spending habits. And my bank account tells me I'm broke and I'm sad. And then everything gets deleted after. So yeah, so this copied successfully, I think happened right here. There's a deposit, I try to withdraw, it tells me I'm broke, and then I withdraw and have a ton of money, and then I, and then my balance gets deleted, oh no. And then it gets copied successfully and I try to withdraw and it gets deleted. Cool. So yeah, I think that's basically it. That's basically what we need to know for our quiz. We need to know the big three. We need to make sure we're comfortable with in like making these three functions. And yeah, you should understand the nuance of how they all work. Okay, this is just extra. I'm gonna make a print function. So if you want to overload, so normally how we print something is we do std count, double less than signs, and let's do trust fund, and then we do std end all. But like the thing is like here, this is red because we actually haven't like defined how our bank account object gets printed. So we have to define that. So here we're going to use something called a friend function. And what a friend function does is a friend function gives this object, this like std count object, access to our private variables. Because you see how count isn't a member of my bank object, so it naturally won't have access to something that's private. But we're going to say that count is our friend and we want to give it access to reading our private, so we have to use a friend function. So we do friend, and what count returns is an something called an O string. So and it returns an instance of an ostream. So we do friend ampersand std ostream. And this is for the operator. This is for the operator. This one. Hold on. Think do ostream there. No, wait, hold on. No, I think we do. Yeah, cool. And then what we're going to take in is going to std ostream and percent. We're going to call it out, and it's going to take in a bank account object. Cool. I think that should work. Let's see. Invalid friend declaration. Dang. Okay, let's make sure. Ostream, 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 ostream. Oh, yeah. So the ampersand applies to the things that's to the left. So right now it's trying to say like, oh, I'm gonna return a friend reference, which isn't the case. I'm gonna return an ostream reference. Cool. Yeah, so I'm gonna return an ostream reference. And yeah, so this is how we set up to print, and I'm just gonna copy this part. Yeah, I should clean this up. Cool. So one of the reasons why we didn't have to use a bank namespace is because this isn't actually going to belong to bank, it's going to belong to ostream, or like any other thing that uses this operator. So this is something that doesn't belong to bank, because for example here, there's no we're calling this operator on an std count object. So it's pretty simple. So we have an ostream on the left hand side, which is here, and you have a bank account object on the right hand side, which is here. And now we're going to return it. So what we do is out, and we're going to do a dot, let's do a dot balance. Oops. Let's do cool. And then we're going to return out. Cool. So what this is going to do is this is going to print. So this is going to take in an ostream object by reference called out. So that's what this does. Remember, there's an out and C out. So it's going to take an object called out. It's going to take an object called bank, which is this. So like this is the function, right? And it takes an out object and a bank object. And it's going to return, it's going to take the out and it's going to stream these things into it, balance, and then the bank account balance, and then it's going to return the out object, which is what it wants. And this should work. Cool. Our balance is only 51. Because the withdrawal doesn't work. Yeah. And if I was to do, if I wanted to, do bill, it would be a big number. Yeah, bill's number is a 1 with 9 zeros behind it. Yeah, cool. And then, are there any other accounts? My AC is going to be the same thing. Yeah, 51 again. And cool. Yeah, that's about it. I hope this made sense. And yeah, have fun and good luck with your quizzes and exams. I'll just make this big so people can see, or if they want a screenshot.